Good day everyone, and welcome back for another video. In today's video I'm going to be short just because I only slept 3 hours yesterday trying to finish the other video that I posted yesterday, and after that an entire day at work, not easy. So I'll be short with this today's video when we're going to talk about this RF choke that I promised. It's quite known on YouTube lately and also on AliExpress. But yeah, I have these two toroids from my friend Vlad, Yankee Sky 5 Bravo Delta Lima. He already built one of these RF chokes for him, and he told me that his noise level went from S4 down to S1, which is quite impressive. So I wanted to build it as well, and he purchased the toroids for me and sent them to me. So I'm going to build this RF choke. Thanks so much, Vlad, for this. And I will not waste your time. We'll do a quick test to test it as a camel mode current choke and see the attenuation level on this one. Until recently, I used this type of RF choke, and I'm quite happy with it. I never had any issues. Somebody asked me in yesterday's video where I have the choke installed. So it's about 20-30 centimeters away from the transceiver side. I don't have an RF choke close to the antenna. I did that in the past, different various versions, you know, like either having the choke really close to the 49:1 impedance transformer, or in my case for the 40 meters band end-fed half-wave antenna, I also placed the common mode current choke 2 meters away from the impedance transformer. But every time I did that, it was changing my SWR slightly, or it was detuning my antenna. Probably it was not detuning my antenna, but it was changing where the antenna was resonating. So since then I moved it on the transceiver side, and I never had any issues. It doesn't change my SWR, doesn't do anything. It works perfectly. I didn't had any issues with common mode current, and on top of that, it doesn't matter if I use or not a counterpoise on the impedance transformer. So in my case right now, for the 40 meters band, I should use 2 meters of wire, or for the 80 meters band version, I should use 4 meters of wire as a counterpoise. I have one right now installed for 2 meters long for the 40 meters band, but even if I take it down, it doesn't seem to have any difference. So yeah, right now it's time to test this one, and I hope it works well. So yeah, let's get into it. But of course, now without saying thank you to my friends at PCBWay for always sponsoring and supporting the DX Explorer channel. They have great PCB prototyping services, PCB assembly, SMD stencils, CNC, 3D printing, and a lot more available for you. Don't forget about all the projects that I designed so far. You have them over there on the PCBWay website, and you can order PCB boards to build the projects that I presented here on YouTube. And they also have the module store that you can also take advantage of that as well, because you might find useful things for your projects. As I'm always saying, PCBWay is the way. Turned on WSJTX, and I'm trying to look at the noise level here on the waterfall. This is with the RF choke connected. Alright, so right now I'm testing the whole thing without the RF choke. I connected the coaxial cable straight to the software. Sorry, to the transceiver, but obviously going through the software. And I'm trying to see if there's any difference in the noise level. I don't know, honestly, I don't see much of a difference. But obviously this is not the proper test, because I actually need a transceiver, you know, to look at the waterfall and see, to have a better visual thing to make a difference. So I'll put on the screen a screenshot from one of my older measurements of this RF choke that I built in the past, and I was happy with the results. but I would like you to see the results that I get with this green RF choke right now. So what do you think about this measurement? It's fantastic. So somewhere around 3 megahertz I have minus 52 dB. By the way, I calibrated the nano VNA before. Somewhere around 3.5 megahertz I have minus 75 dB, somewhere around there. Let's go all the way down to the 10 meters band, somewhere around 30 megahertz, and I have again minus 75, somewhere around minus 71, 75 dB of attenuation. So definitely I understand why this green toroid works the way it works. So again, this is the toroid. I will talk more about this one. Definitely I will talk more about this one, and probably I can do a little tutorial on how to build this RF choke, but it's quite easy. Who knows, if you want to try to build it, it's 5 turns on one side, 5 turns on the other side, and there's a crossover between these two after the 5th turn. So the 5th, sorry, I have, let's see, 1 2 3 4 5, oh sorry, the 6th turn goes through, and then I have 1 2 3 4 5 over here. So this is the RF choke, simply with these two toroids. I'll put a link down in the video description if you want to purchase this one. But yeah, now I understand why the noise level goes so down, so low, and definitely is good and as a common mode Korean choke, so I don't have to use two chokes in the same line. So, oh my god, Vlad, I promised I will do this video. I made it. Interesting.